So that's what you need to remember. Okay, so if you understand that, I think the rest complete table, you will understand it very clearly. What exactly is this? What is the meaning of this notes? I want all of you to just remember the number order what I have in the notes. So let me not tell you each and everything. So let me not bore you guys by explaining each and everything that I have here. So we are trying to take this again with a reconstruction, remodification to the next date problem. Hello everyone, I welcome all of you to the last session on integration testing. So my dear students, hope all of you have seen the session number 1 and session number 2. Here I am presenting session number 3 for all of you. So to complete the concepts, whatever I have with respect to the integration testing. So guys, integration testing is one of the important topics that all of you should know in the unit 2. Alright, so guys, without wasting much of your time, let me discuss what I have in this session for all of you. So guys, basically I will be starting my session with a continuation topic of neighborhood, and also I will be discussing one of the important part of this chapter, that is going to be the case study. Yes, what is that I have in the neighborhood that I wanted to know? So guys, let's start with this. My dear students, before I get into the concept, I want all of you to please look at the graph that I have. So what is this? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You're showing us the numbers of the graph. What exactly is this? What is the meaning of this notes? I want all of you to just remember the number order what I have in the notes, because I will show you the graph with respect to the same thing with respect to the next date problem. Alright, so guys, please remember this. Before that, I will also discuss some of the important formulas to calculate the interior nodes, and also you will also be able to calculate the neighborhoods. So what is the formula to calculate the interior nodes? My dear students, you need to remember nodes minus source node plus sink node will give you the interior nodes. Sir, what is source node? What is sink node? So what is node? I have defined that in detail in my previous session. So please go back to my previous session and watch the definitions of what is source node, what is sink node, and what is node. So if you watch that, so you will understand so this very clearly. So just tell you quickly, source node is nothing but the node which I have here. And the sink nodes are the nodes which you have in the bottom. So that's what you will be called as a sink node. So that's what you need to keep it in your mind when you're seeing this formula. In the same way, I have for the neighborhood also. What is the formula to calculate neighborhood? Please remember, interior nodes plus source node is what you need to remember. And also which combines nodes minus sink nodes will also give you the neighborhood. So that's what you need to remember with respect to these formulas. Yes. So my intention, my topic here comes, guys, please look at this. So I have the main calendar program. So I have represented that now in this manner, okay, in this graph. That's what you need to remember here with a functional decomposition. So I want all of you to please look at the nodes and the numbers. Please remember the numbers. This is 1, okay. This is what I will call it as a 1, 2, 3, 4, 5. The same order what I had here. Remember that, okay? So 1, 2, 3, 4, 5, 6. In the same order I have here. So 1, 2, 3, 4, 5, 6. So why are you saying this? I will tell you that. So please remember. So 6, 7, okay? 8, 9, 10, 11, 12, 13, 14, and 15. So this is what you need to remember, guys. Yes. Now I will come to the picture. Guys, I have done a table. So this table will give you the clear idea about the neighborhoods in the calendar program. So using the call graph. So what is this? I have a call graph and I have taken the calendar program. Here I have the calendar program. Next, I will also take the next date problem. Alright, so fine. For a calendar program, so how do I represent the neighborhood using the call graph? So please observe here. So first column, I have taken the nodes. So this is the nodes. Okay, so hope all of you are able to see this. Node 1, 2, 3, 4, 5, 6 till 15. So that's what I have tried representing here. That's the first column. The second column that I have here is unit name. So this is what I will call it as a units, whatever I have here. So this is what I'm calling it as a units. So I have 15 units. Each node has got the name and I'm calling that as a unit is what you need to remember. All right. So that's a very important thing that you need to remember here. So fine. Then after that, I have two things. One is predecessor, another one is successor. Okay. I'm just trying to understand so the relationship, like, who is there next and who is there behind me. Okay. I'm the node. So who is there next to me and who is there behind me? That's what I'm trying to understand with respect to the call graph. All right. So let me start with the first one. So guys, I have the calendar. What is the first unit that I have? I have the calendar. So for this, I'm checking who is the predecessor and who is the successor. So there is no predecessor here. So that's what you need to remember. I have, so these many successor. That's what I have tried representing here. So 2, 3, 4, 5, 6, 7. Sir, what is the meaning of 2, 3, 4, 5, 6, 7? 2, 3, 4, 5, 6, 7. So that's what you need to remember. Okay. So if you understand that, I think the rest complete table, you will understand it very clearly. Moving forward to the next one. So I have the next unit, that is get date. Let me erase everything now. So you'll understand, right? So the next one that I have is get date. So please remember. So for the get date, who is the predecessor? I have one as a predecessor. That is this calendar. Then who is the successor? So please understand, successor is get date, get digit and date to date num. So this too is the successor. So this is what you need to understand with respect to the neighborhoods in the calendar program using the call graph. Hope you understood this in a simple way. So guys, you just check out this table so you will get the complete information about how exactly the neighborhood you have in this call graph. But one more important topic that I have. So the same thing I can also represent it with the help of adjacency matrix. This is what I will call it as adjacency matrix. So how do I represent in the adjacency matrix? Let me tell you that in a very simple way. So guys, this is the adjacency matrix that I have. So please observe, there is no big deal. Let me make it very simple for all of you. So I have 15 rows. So what are the 15 rows? So I have 15 units. So that's why I have 15 rows. The same way I have 15 columns. That's what you need to remember. All right. So fine. Observe here using this graph. Okay. The same graph I have taken. So guys, what is that I have? The first node, right? So that is the calendar main. Okay. The first unit. So please understand the first unit. So has got the relationship between. So it has got the link. Okay. With the second one. That is second unit, third unit, fourth, fifth, sixth, seventh. That's what you need to observe here. So observe here. So one has got the relationship, that is successor with 2, 3, 4, 5, 6, 7. That's what I have marked it as 1. All right. So hope you understood this. Now coming to the second one. Second is this one. So this is the second unit. Okay. So this has got two successor, that is 8 and 9. So please observe here. I've marked 8 and 9 as 1, 1. In the same way, I'll go to the third one. So please check. The third one has got one successor. So please check here. Third one has got one successor. That is 9. So like this, for all the nodes, so till 15, I will be marking with the adjacency matrix. And finally, I will be calculating the row sum as well as the column sum. That's what you need to remember with respect to the adjacency matrix. Hope this is very simple for you all to understand. So let me not tell you each and everything. So let me not bore you guys by explaining each and everything that I have here. But this is very simple and I want all of you to please go through with this. All right, moving on to the next topic that I have. Guys, the very important topic that I have today is all about the case study. You might get this for your examination. So what is that I have in the case study? So please understand, I will be discussing the integration of next date problem, the very old and the classic problem that we have already discussed. So we are trying to take this again with a reconstruction, remodification to the next date problem. So we have done some of the changes in the next date problem. So let's see what exactly is that. Along with that, we will also discuss decomposition based integration and call graph based integration and MMPath integration. So we will check all these things with respect to the next date problem. So that's going to be your case study today. All right. So fine, let's start that without wasting much of your time. So guys, the first thing that I have is decomposition based integration. So you all know that. I don't have to explain much about this decomposition. You all know that. So you will be dividing it into different multiple subsystems until you get the last individual unit. That's the most important point that you need to remember with respect to the decomposition. So fine, we know that, sir. So please observe this carefully. So I have integration next date. So that's what I have told all of you. So I'll be discussing the integration next date. So when I take this, I have the subsystem as isLeap, last date of month. Okay, get date, increment date, print date. So all these things are the subsystems that I have in the first level. So please check and remember what is that I have, the remarks with respect to this. The leap year, that is isLeap, and the last date of month functions are in the first level. So please observe, these two are in the first level. And what is the reason behind that? So please observe, because they must be available to both get date as well as increment date. So get date as well as the increment date. This is the first point that you need to remember with respect to the decomposition based integration of integration next date. So fine, we remember that, sir. Pair integration, pairwise integration based on decomposition is a problematic. Why? Why it is a problematic, sir? Please remember, now I have the point for all of you. The isLeap, in the sense this subsystem, isLeap and the last date of month functions are never directly connected to the main program, that is integration next date. That's a major problem that I have here. So what is the reason behind it, and what will happen? What is the effect of it? So please remember, so that this integration sessions would be empty. If I have that, so please remember, so this integration sessions would be empty. That's the major problem that I have. So to solve this problem, my dear students, I am going for the next concept that I have, call graph based method. So fine. Let us check how exactly this will solve my problem. So somehow it will solve my problem. There are no empty integration in the call graph method. So please observe, there is no empty sessions in the integration sessions, because the edges refers to the actual unit reference. I have the edges here. So this will help me to avoid the empty sessions. That's what you need to remember. But I have one more problem here also, even in the call graph. What is that? I have the problem with the stubs. I have to create the stubs. Please remember, so there is still the problem of stubs. So how do I solve this? So I couldn't solve this with a pairwise integration, but I will be able to solve somehow with a call graph, right? So please observe here. So I have the problem here. Okay, how do I solve this with the next solution? So what is the next solution then? You all studied, okay? We have a concept called sandwich integration. So please remember that. Sandwich integration is appropriate because this example is so small. So do you remember when I have a sandwich integration, I'll be taking complete thing, okay? So this complete thing I was taking for a sandwich, but when it is with the too many units, it is very difficult. That was the drawback of sandwich. But in this one, I have too small system. I can take it, is what they are saying. In fact, it leads to itself a build sequence. Build sequence, not only in one prototype or not only in one module. So it will take a build sequence, is what you need to remember. So fine. When it takes a build sequence, what will happen? When the build one could maintain the main and print date, but build 2 could contain main, increment date, last date of month, and also increment date in addition to that already present print date. So I have 2 builds. The first build, it will take the main and print date. When I have the second build, I will have all this subsystems. That's what you need to remember here. Okay, so fine. Neighborhood integration based on the call graph would likely proceed with the neighborhood of validate the last date of month. So this will solve your problem, is what they are trying to say with the call graph based integration. So fine. Moving forward, this is very important with respect to the call graph based integration. And also I will be using the one of the important concept, that is path based integration. So now I will also demonstrate what exactly path integration. So guys, when I'm using the call graph based integration, I will also discuss some of the important concepts. I've taken some of the important concepts with respect to the path integration. Sir, what exactly that I have in the path integration? My dear students, in this 3 parts, I have taken your next date program. Okay, I've taken your next date program with the line number. So I'm using this path. Okay, so path integration graph. So let us understand this graph, how exactly this is working. So please observe. So this is what I have. I will call this as a main graph. Okay, so please observe this, and this graph what I have, this will help me to get the date. Okay, this is what I have. This will help me to validate the date. Okay, so that's what you need to remember, and this is what I have. This will help me to calculate the last day of month. So this is how I have divided the graph. Now, that is the first thing that you need to remember. The second thing that you need to remember is each line in your program has got the line number. So that is what in this graph I have represented with the nodes. Say for example, here I have 1 inside the node. So that is what you need to remember. So the line number 1. So I have 2. So line number 2. It is pointing to the line number 2. That's how you have to remember the entire graph. Alright. So fine. That is the second point you need to remember. The third point. When it comes to the third point, so please understand, so what is that you need to remember? path will help you to get the feasible execution part of that particular program. So that is one of the feasible solution that you have to avoid the unnecessary information that you will be getting with respect to the execution of the program. So guys, let us check what is that I have in my screen. So guys, so what is that I have here? Let us take this diagram and then we'll trace it back how exactly this is working. So like that we will understand. So fine. So guys, I have 1. Okay, in this graph, I have node number 1 and I have taken node number 2. This node number 2 is sending the message 1. So please observe, node number 2 is sending a message 1 to the node number 34. So node number 34, remember that. So now I will show you here what exactly is happening here. So I have line number 1. So find node number 1. So I have no issues. After that, it will go to the node number 2. So in the node number 2, it sends a message 1. What is the message 1? So get date is a function of today. So that's what it is calling. It is calling one function get date of today. So from here, the control will go to the line number 34. That's what you need to remember. What is that I have in the line number 34? So the execution from here, it jumps to line number 34. So line number 34 is a function that I have defined to get the date. So that's what you need to remember. So fine. So then after that, it will start executing. So it will start executing. That is what you need to remember. So it will reach the line number 66. What is that I have here in the 66? So I have a function called again until valid date. Until a valid date. I'm calling one more function until a valid date. So fine. From line number 66, message is sent to line number 35. So what is that I have line number 35? So guys, please observe in the line number 35, again, there is a function called to validate a date. So from again, now when I was executing this, again from here, the control will jump to this. So it will start executing this function. So then after that, what happens here? So all these lines will be executed based on the condition, what they have taken. So then finally it reaches the 55, line number 55. So when it reaches the line number 55, what do I have in the line number 55? So that's the end of the guys function validate date. Then after that, it returns a message to line number 67. What is that I have in the line number 67? End of the function get date. So from here, again, I'm getting the message back to the line number 3. So I wanted a date. So all these things is calculated using a different functions. And I'm getting the message back to the line number 3. This is how the path is being represented. So in this graph, that's what you need to remember here. So I have the complete program, how exactly the execution flow of that program is happening. So that is what I'm trying to represent in a feasible way using the concept of path. That's what you need to remember here. The same way I have considered the path for the next state integration here. The same thing what we have discussed in the previous thing. So guys, I have a small comparison between all the 3 techniques what we have discussed. Especially this is very beautiful and important concept to conclude this chapter. What is that I have? So guys, I have listed out 3 strategies. The first strategy is all about the functional decomposition. The second one is call graph. The last one is path. So this is the 3 strategies that I'm going to compare now. So fine, ability to test the interfaces. Interfaces in the sense I have 2 units. So when I'm connecting 2 units, so the between which comes is interface. Alright, that's what you need to remember. So ability to test the interface, which technique or which strategy is good. So please observe, acceptable. So when it comes to the functional decomposition, I can do that, can be deceptive. So that's what the idea that you need to remember. But when it comes to the call graph, yes, of course it is acceptable, but when it comes to the path, it is excellent solution or the strategy if you are testing the interface when it is coming a concept of integration testing. So fine. When it comes to the ability to test the core functionality, so of course the functional decomposition will give you the limited to the pairs of units. You cannot have multiple pairs. That is the disadvantage that we have. Again, the same thing with the call graph, but so you will have the complete thing with the path. So that's what you need to remember. In the fault isolation resolution, so when it comes to the fault isolation resolution, please remember, good to the fault isolation resolution, the same thing will happen for the call graph also, but when it comes to the path, excellent to the unit path level. Excellent to the unit path level. That's what you need to remember. So guys, if you ask me, the best solution that you have here is the path. All right. So by saying this, I will be winding up the chapter called integration testing. Thank you. Bye-bye. Hope the information was helpful to all of you. If you have liked it, so guys, please don't forget to click on the like button. Thank you and share the video.